Welcome to lesson 2.3.1, rational functions. A rational function is the ratio of any two polynomials that can be written in the form f of x equals p of x divided by q of x. Of course, q of x cannot equal 0. I think there's some disagreement here about whether q of x can be 1. Normally, q of x is a linear function that is not a horizontal line, but some linear function with a variable x, or a quadratic, or a cubic, or some other type of polynomial. But in general, a rational function will have a variable in the denominator. And so that's kind of what we're looking for. If you look at this, I'm kind of showing you a textbook page. This is your textbook, and you do have access to your textbook at home. If you go to Mathiad, there's a link to find your textbook. So I would encourage you to use that. There is a glossary. There are notes. There are examples. There's different things in here that you can read to kind of help you learn as much as you can while you're out. So I'm just kind of reviewing a couple of definitions here, and then we'll get to the assignment that you have to complete. So the next page, if you turn to 135, it's talking about a vertical asymptote, and it says the function g of x equals 1 over x as a vertical asymptote at x equals 0, and it's like a boundary line. It's a vertical line that your graph can get close to but can never intersect, and the reason is because if you have an asymptote, the denominator will equal 0 there. And you can't have a denominator equal to 0 because that means you're dividing by 0, which is not okay. So sometimes we show the asymptotes and sometimes we do not. So we'll show how that works in just a minute. And then they go on to talk about different notation for your domain and your range. And you've seen the domain and range of your rational parent function. So you kind of already know, hopefully, what this looks like. I've created a rational function in my calculator. I went to y equals and typed in y equals 1 over x minus 2, and then I think I'll change this to second zoom. I'd like to see my grid lines, so let me go turn those on. You graph, and there's your function. So you may be able to tell it's not touching the 2. And you can really tell if you type trace 2 because it's blank at the 2. There's no y value there. There are no points. So the first answer for your assignment under right, it says describe why a rational function never crosses its vertical asymptote, would be this statement. So let me pull this over. A rational function has a vertical asymptote or boundary line when the denominator is equal to 0. The function cannot intersect the vertical asymptote because every point on the asymptote has an x value that would make the denominator 0. It is not possible to divide by 0. So that's basically in a nutshell. And so the entire study of rational functions is studying functions who have denominators that could potentially equal 0, and so that produces those boundary lines. Practice question 1. Consider the function f of x equals 4 divided by x. Complete the table. Use the table to graph. Analyze the function and corresponding table and graph. Describe the domain, range, and behavior. And determine all of the asymptotes of the function. Explain your reasoning. Well, you don't technically have to write much down here except for the answers to question C. So A and B, we're going to do all of those things in the Desmos calculator. If you will click on the link that you've been provided, it's going to take you to the graph that's here. So you see the function f of x equals 4 divided by x is already graphed. The x coordinates are down here in a table that's already been created for you. So what you're going to do is you're going to put f of x1, it'll automatically make it a subscript. I spent a long time trying to figure that out. But you'll notice that at 0, that this function is undefined. So that is telling you your vertical asymptote. Now, if you want to really see your vertical asymptote, click down here and just say x equals 0, and it'll include a line. You will definitely want to change the color though so you can tell. Let's see, can I change this color? I think I can do that up here. Oh, maybe not. I want color, yeah. Alright, so I'm going to make it, let's do it like that. Dotted and blue. Done. So look at that boundary line. It's real bold and easy to see. So now we have an asymptote. You can also click on points on the line, and it'll kind of show those points if you want to see an ordered pair, which is kind of interesting. But if you filled out this table, then you should now be able to answer some of the questions in the document. So just use this to help you. You can also share out this graph. If you want to export the image, you could take the image, make it thick or thin or whatever, and you could download it and you can put it in your document if you want to. I'm not going to make you do that, but because I've already given you the graph basically. So let's go here and look at your practice question. It says to analyze the function, the table, and the graph, describe the domain, the range, the end behavior. Well, first of all, the domain of this function in your calculator, so we're going to find it, there it is all real numbers except the 0. So you can pretty much have any value of x you want, but you cannot have a value x of 0 because that's going to give you a 0 in that denominator. So the domain is from -infinity to 0, and then again from 0 to infinity. So let's see how we would type that. So I'm just going to type domain, and let's use our equation editor here. So if you'll do insert equation, so we open parentheses, -infinity, let's see where that is. It's in here somewhere. There it is. To 0, then close your parentheses, and then we need to put our little U shape in here. Let's see if I can find it. No, here it is. And then we're going to go from 0 to infinity. So we'll insert, well, where am I? Wrong button. Infinity. All right, so this is your domain. I guess I could have made this red or something so it'll stick out, but that's fine. All right, next it says the range. Well, the range is sort of like the domain. Let's go back to and look at it again. The range is also going from -infinity to 0. It doesn't touch the x-axis. That's where the y is 0. And then it goes up forever. So the range is the same. So I'm just going to copy this, and I'm going to paste it here. All right, next it says the end behavior of the function. So basically, as x goes to -infinity, what is happening? Well, the y is getting close to 0 from the bottom. So you would say it like this. As x approaches, so we've got a symbol for that. So I can find it. As x approaches infinity, comma, y approaches 0 from the top. Let's see if I'm right about that. Let's look at it. Yeah, it's going to approach the 0 from the top, so I'm going to put a plus sign there. That should be a superscript though, so let's see if it'll let me do that. I'm just going to get out. That's a good idea. Let's go to edit, format. There you go. I got a plus in there. All right, so as x approaches infinity, y approaches 0 from the top. So that's how you would say that. Okay, on the other side, as x approaches -infinity, so I'm just going to copy this. Oops. So we're going to say as x approaches -infinity, y approaches 0 from the bottom. So that's going to be a minus sign, not a plus sign. Determine all the asymptotes of the function. Well, there's a vertical asymptote at at x equals 0. That is your y-axis. So x equals 0 is a vertical asymptote. Oops, we better get out of this. Control. Let's put in an equation. So the vertical asymptote is x equals 0. And the horizontal is going to be y equals 0. There we go. All right, explain your reasoning. Well, you don't have to write this down, but basically the horizontal asymptote happens as x gets larger and larger. Think about it. If you have 4 over a million, 4 over a million is going to be really close to 0. And 4 over negative a million is also very close to 0, but it is negative. So as you are going left, it's going to keep getting closer and closer, but it'll never reach 0. It'll just keep getting closer as you go left and as you go right. If you would like to put in the horizontal asymptote, we could come down here and put it y equals 0. And then you could change it up here with the gear. Make it a dotted one, maybe make this one orange or something. And then you can see your horizontal asymptote is the other one on the graph. Okay, practice question 2. Consider the function h of x equals 8 divided by x squared. Complete the table. So the values are the same in this table. And then we're going to analyze the function. Now, I've written down the same domains, ranges, and everything, so I would not do that. Don't copy that. I just was being a little lazy there. All right, so I'm going to show you how we can go up here and just change this function to 8. I believe it's 8 over x squared. And it's just going to change everything. So you will notice you still have the same asymptotes that you had before, but the branches are going in a different direction, and that's because you have an x squared in the denominator, which means it's impossible to have a negative y value. So the y values, as you can see here, are all positive. The first ones are positive and the second ones are positive, but they're repeating. So the same 5 numbers that appeared in the first 5 rows of your table are the same numbers in the last rows of your table because they are symmetric. So let's go down here and let's see if we can adjust these answers. I just copied and pasted the answers to the previous problem. So the domain, it says it goes from negative infinity to 0 and 0 to infinity. Well, that's still true. It goes from the left until it gets to this line, and it cannot reach that line. It says undefined in this table. So yeah, that's good. So the domain is going to stay the same for this problem. So the next thing is the range. Well, this is different because there are no values below 0. All of the y values are above the x-axis. So what you want to do for your range is just put 0 to infinity. So let's get rid of negative infinity to 0 and just put the 0 to infinity. All right, what about the end behavior? Well, let's see. As x approaches infinity, in other words, as the graph goes to the right, the y value does go to 0, but it's from the top, not the bottom. So that part, this part's right. If you go to negative infinity, that means you're going to the left. Then the y values still approach 0, but instead of approaching from the bottom, they approach from the top. So let's change this sign to a plus sign, and that's supposed to be a superscript, so let me fix it. Text superscript. All right, so both of those will be plus signs. There is a vertical asymptote at x equals 0. That is true. It does not touch the y-axis, so this vertical line was x equals 0, and there is a horizontal line asymptote at y equals 0. So you see I still have that on here. It does not touch it. It does look like it at the ends, but it doesn't. It just keeps getting closer forever. Okay, the last question in your packet is complete the table to show the amount of time it would take to save $2,200 for different weekly savings amounts. So if you save $10 per week, how long is it going to take you to reach $2,200? So that's just simple arithmetic. So what I'll do is I'll go in here. I'm going to delete all this. We're going to start over because it's kind of a mess, just to be honest. Let's take, I'm going to drag this in, and let's do this. Let's add a table. And in list 1, I put, let's put the first amount that you were given, which was $10. It's 10, 20, 40, 50, and 100. So let's just go ahead and put all those. 10, 20, 40, 50, 100. All right, so the first number is 2,200. So I'm going to come down here and do the math. 2,200 divided by 10. And so that amount, it'll display it right below. It'll tell you what that is. So I'm going to put the amount in here, 2,200. All right, so let's do 2,200 divided by 20. And I'm getting 110. And you might notice these points showing up. I'll show you how to fix all that in just a second. All right, 2,200 divided by 40 is 55. 2,200 divided by 50 is 44. And 2,200 divided by 100 is 22. All right, so you can see how the graph is sloping. We're only seeing the first quadrant, so that's kind of hard to really make sense of that. But I'm going to zoom in. I'm using you can use this plus, this minus. Plus to zoom in and minus to zoom out. So I'm zooming in with the plus. Well, I think we're good there. You probably want to be able to see that 200 up there. So if you want to adjust your x's, it says I'm counting by tens. So we can go from 0 to, I guess, 100. Better make that 110. There we go. All right, that looks pretty good. So you're getting the idea. So let's answer some questions. It says in your handout, create a table graph equation for this function. You can copy and paste your graph from Desmos, describe key features. Well, we kind of have a graph of just of the points. So let's see if we can come up with a function. Well, you may notice we divided these. We divided 2,200 by these values to get our y value. So that is your function. Your function is y equals, or f of x equals, 2,200 divided by x. And so you'll notice that function just appeared on top of my graph. To get your domain and range set, you may want to set your x's. You want to go past 100 so you can see this point. And your y's need to go up past 220. So this is the window I have. You could do anything similar to that to be able to see it. All right, so let's see, what is the question? Describe key features of the graph. Well, it does have a horizontal asymptote at 0. So I've got these. Let me make these pretty for you. There we go. The horizontal asymptote is at y equals 0. And that's because you're never going to reach a 0 amount by dividing. You could have 1,000,000 weeks. You're still going to have some money. I don't know, 0.00001 penny, but you'll have something. So the number of weeks can go indefinitely up, but you'll never have a y value that's 0. And the other way works too. It can ever equal 0. Your x can never equal 0 because if you have 0 weeks, Yeah, I guess you could have 0 weeks and start with 2200, but in this scenario, it won't touch the y-axis. It'll go up forever because you could do 0.0001 weeks. And so it could keep going past 2,200. The graph is decreasing, as you can tell from left to right, it's decreasing. And then the end behavior, as x approaches infinity, the y approaches 0. It's approaching it from the top, but that's because there are no negatives in this situation, so I didn't even put that. And as x approaches 0, as it comes in from the left, the y keeps going up forever. So you could put that. That's not really considered end behavior. That's actually short-run behavior, but it's important. So let's describe that as one of the key features of this graph. This is a nonlinear graph. It's a curved graph. Those are other things you can add. It is a rational function because it does have the variable x in the denominator. So those are your key features. So this is the end of your assignment. As long as you've answered these questions, then you've done sufficient work on this part of the assignment. The last thing you'll do is complete the exit ticket, which is just a simple, short quiz over the basic concepts that are in this lesson. Y'all stay safe. I'll see you again for the next lesson on Monday.